Writing on this board says that we are going to design a water fountain. The question that I am going to discuss today is based on few simple facts that students learn in class 11th physics. This is a tall cylindrical tower. Let us say this tower has some well-defined height edge. It is quite tall so that you get a nice fountain, and water is filled into this tower, cylindrical tower, and water level is always maintained by pouring some water. The water level is always maintained inside this cylindrical container. The walls of this cylindrical container are perforated. It means there are large number of small holes punched on the entire surface of the cylindrical container. These holes have a small cross sectional area, very small cross sectional area as compared to the dimension or the radius of the water cylinder, the tower. To give you a beautiful appearance, we will plant some multicolored lights if possible. To give it a beautiful appearance, we can put on some light over here. So when the water jet comes out through all these holes and light falls on it, it gives it a beautiful appearance. So this is the water fountain we are talking about, but what exactly is the question? The question is, what will be the shape of the water fountain? The water that is coming out, light is falling on it, so it is looking beautiful, but what is the shape of that flower of water or cloud of water or fountain of whatever you wish to call it? What will be the profile of water jet that is coming out of this cylindrical tower? So let me reiterate some of the assumptions that we will be taking up here. Water level is maintained at the original level in this cylindrical tower. Holes are large in number and small in size. There are many holes and all of them are very small compared to the radius, cross-sectional radius of the cylinder is quite large compared to that of holes. Assume water jets do not interfere with each other. When water jet is coming out of this hole, this hole, this hole and this hole, most likely they will interfere with one another, isn't it? But we will assume that water jets do not interfere with each other and disregard any effect due to air resistance. So water is coming out from this hole, this hole, this hole, all of these holes. They do not interfere with one another. That means water jet coming out of one hole will make no change in path of water jet coming out of the other hole, which in practice looks a bit absurd, I would say. They will interfere with one another, but to keep our question simple, we will assume there is no interference. What is the shape of the water fountain? That is the question, and if you wish to give it a try, you can. Please pause the video and give it a genuine try, and let us hope that you get the answer right. Here I am proceeding with my solution. So I have drawn a simpler diagram. This is our tower and it has been filled with water up to, let us say, capital H height. For the sake of simplicity, I am assuming this is the water level, top surface of water in the tank. Let me assume this point as origin, horizontal as x-axis and vertical as y-axis. Let me set up my coordinate system like this. Now think of a hole that is there in the wall of the cylinder at a depth, let us say h below the water surface here. This depth is h. Now according to Torricelli's theorem, we all know that water particles will eject out from here at a speed of under root 2gh, and in absence of any interference from other water streams, in absence of any kind of air resistance, these water particles are bound to follow a parabolic path. A simple understanding of projectile motion tells you that yes, these water particles are going to follow this trajectory which will be parabolic. In our coordinate system, where we have taken this as origin, this as x-axis and this as y-axis, let us write the path equation or the trajectory equation of any one water particle which is being emanated from this hole and is following a parabolic path. It is quite easy to do it, and I hope all of you will be able to do it. To just give you a guidance, let us assume that at time t, after getting ejected out from this hole, at time t, a particle is here and its coordinate is x comma y. So, if you take this point as origin, I guess most of you do remember the equation also, but the only thing that I have changed here is I have taken this point as origin. It hardly makes any difference, isn't it? So, at time t, the x coordinate of the particle will become equal to u into t, right? Because particles will be traveling at constant speed u in this direction, horizontal direction. And in time t, it would have fallen through a distance half gt square. So, the original y coordinate is h, so h plus half gt square. So, this becomes h plus half gt square. Now, you eliminate t between these two equations, and in place of u write under root 2 gh, and you will get the required trajectory equation. The required trajectory equation looks somewhat like this. You can prove it yourself. Just eliminate time, and in place of u, you have to substitute under root 2 gh. So, you will get an equation of this shape. What does this equation tell you? This equation tells us that if there is a hole at a depth h below the water surface, and if a water particle ejects out of this hole at a speed under root 2 gh, then it will follow a parabolic trajectory, and the trajectory equation is this, which means we can easily locate the particle. If I know the x coordinate, I can find its y coordinate. This is what it tells you. So, for different values of h, because there are multiple holes at different depth h, so for different values of h, we will get different parabolic curves. If we consider a hole over here, then might be the water particles being ejected from here fall somewhere here. If you consider a hole over here, they might be falling somewhere here, right? If you consider a hole here, might be the water particles will go like this. If you consider a hole here, they will again fall here. If you consider a hole here, they will follow a parabolic path like this. So, there will be different set of parabolic paths for different holes falling on this vertical line. Mind you, we are considering one straight vertical line, and we are assuming multiple holes located on that particular line. Right now, we are doing this. So, we will get a family of parabolas, set of parabolas, right? And what we need to find is the common envelope. If you are looking at it from outside and there are multiple water jets like this, what does it appear like? This cloud of water will appear like this, as if it is a dense cloud, then obviously it will appear as if everywhere there is water, 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 water. And if you are throwing light, basically you will see light all over here. So, the question is basically to find this profile. Is it a hyperbola? Is it a straight line? Or it also is a parabola? Want to make a guess? Do it right now. I have given a lot of hint by trying to draw this shape actually. You can take it on from here. I can put this equation in this form. This is the trajectory equation. I have put it into this form. I have purposefully written it in this form. I want you to see this as a quadratic equation in H. I want you to look at this equation as a quadratic equation in H. And please try to understand that a water drop can reach any given point x comma y only if this equation gives you a valid real root of h. Suppose you just choose any random point as x is equal to a and y is equal to b. This is the coordinate of a random point that you have chosen. In place of x you write a, in place of y you write b. You solve this quadratic equation for h and it gives you an absurd value, means imaginary value for h. What does it mean? It simply means that no water particle can pass through this point. Of course, we have a limitation. We have a limitation that height of our tower is limited. So, which means capital H, small h cannot be greater than capital H. Small h cannot be less than 0. So, if solving this gives me a value of h which is less than 0, it does not make any sense. If solving this gives me a value of small h which is larger than the given height capital H, then also it does not make any sense. Most importantly, this equation should give us a real value of small h. Imaginary value just does not make any sense, which simply means for no value of h, we can have a water particle crossing through this particular point. So, a water drop can reach a point x comma y or a comma b, whatever you want to call it, if this equation gives you a real value of h. So, if this is a quadratic equation in h and it has to give us a real value of h, then this is possible only if discriminant of this equation happens to be greater than 0. So, discriminant here will be actually 16 y square minus 4 4 just 16 x square. This is greater than or equal to 0, which means y square is greater than or equal to x square. Obviously, if we consider only positive values of x and y, look at our diagram, it makes a lot of sense to just consider positive values of x and y right now. This simply translates into saying that y must be greater than or equal to x. Y must be greater than or equal to x. What does it mean actually? It simply means that the profile that we are looking for will be a straight line y is equal to x. This is our origin. Just draw a line y is equal to x here. That means a straight line making an angle of 45 degree with x axis like this. Right. Y should be greater than x means we cannot have a point like this. Here x is greater than y. On this blue line, x is equal to y. So, at all these points, y is greater than x, and all these points have coordinates having x greater than y. So, what we actually want is y should be greater than or equal to x. If you wish this equation, if you want this equation to give you a real value of h for which a water drop is passing through a point x comma y. I hope I am not confusing you. If you are randomly taking a point x comma y, a comma b, whatever, and a water drop has to cross through this point, then this equation must give me a real value of h, which is possible only if y is greater than or equal to x. What does it mean actually? It simply means that the point we are considering should be below this blue line. At all these points y is greater than x, and at all these points y is less than x. So, if y is less than x, x is greater than y, then you cannot have a water drop passing through this point. This is what we are saying for any real values of h. So, obviously, whatever be the height of this cylindrical tower actually, start from the top, draw a line making an angle of 45 degree with horizontal, and we are confident that each and every water particle will always lie within this region. No water particle will be outside this blue colored line. So, now if you extend this to a 3-dimensional case, what is happening is this is the 45 degree blue line, and because it is a cylindrical tower, it is throwing water in all directions. So, just rotate this line about the vertical, making an angle of 45 degree. For a moment, just for the sake of simplicity, assume that this cylindrical tower has no thickness. Just for a moment, assume that this cylindrical tower has no thickness. In that case, this blue line can be rotated about this vertical line. making an angle of 45 degree with vertical or horizontal, and you will get a cone. You can see a cone. So all water drops will lie inside this cone only. No water drop can be outside this cone. So you will get a conical water fountain, isn't it? If there is some width of this cylindrical tower, which of course it is there, in that case it will be a kind of truncated cone, something like this, and this will be the shape of the water fountain. And in case you can ignore this width of the cylindrical tower, then it will almost appear like a perfect cone. Put on some lights over here, throw some lights on the water drops. Water drops are going to scatter the light, they will reflect, disperse, and you can see a beautiful fountain. Goodbye.